Assalamu alaikum and namaste mere pyare dosto and welcome back to Mobrur Hussain Chowdhury ke channel main. To aaj hum log jaanne wale hai world will be destroyed in 2038. Chalo shuru karne hai bina bakchodi ke. I'm sure you've heard the news. The year 2038 may seem distant, but whispers of its arrival bring a chill to some. Could our world truly end in 2038? This question, fueled by internet rumors and doomsday prophecies, has captured the imaginations and anxieties of many. The truth, however, is often less sensational and more nuanced. This essay will delve into the origins of the 2038 prediction, exploring the potential threats and separating fact from fiction. We will examine the infamous 2038 problem in computer systems, a real issue with manageable solutions. We will also investigate the likelihood of catastrophic events such as asteroid impacts, cosmic events, and runaway climate change. By understanding the science and engaging in critical thinking, we can dispel unfounded fears and focus on the real challenges facing humanity. This essay will conclude by emphasizing the importance of proactive measures, scientific advancement, and global cooperation in ensuring a brighter future for generations to come. At the heart of the 2038 doomsday prediction lies a technological issue known as the 2038 problem. This problem, while not as widely known as the Y2K bug, has the potential to cause significant disruptions if not properly addressed. This problem arises from the way many computer systems store and manage time. Specifically, it is rooted in the limitations of the 32-bit integer system used by many older computer systems. These systems use a 32-bit integer system to count seconds since January 1st, 1970, at 0 hours, 0 minutes, and 0 seconds, Coordinated Universal Time, UTC. This method of timekeeping, known as Unix time or POSIX time, has been a standard in computing for decades. The issue? This 32-bit system has a finite limit. It can only count up to a certain number of seconds before it runs out of space to store the value. On January 19, 2038, at 3 hours, 14 minutes and 7 seconds UTC, the counter will reach its maximum value and reset to 0. This reset could cause systems that rely on accurate timekeeping to malfunction, as they may interpret the reset as a return to the year 1970. This could cause systems that rely on accurate timekeeping to malfunction. The potential consequences of such malfunctions are vast and varied. Imagine potential disruptions to financial transactions, transportation systems, and power grids, a digital chaos. Banks could face transaction errors, trains could be delayed or cancelled, and power grids could experience outages, all due to the inability of systems to correctly process the date and time. However, unlike the Y2K bug, which caused widespread panic as the year 2000 approached, the 2038 problem is well understood and is being addressed proactively by software developers and engineers. The lessons learned from Y2K have prepared the tech community to handle such issues more effectively. By transitioning to 64-bit systems or implementing alternative timekeeping methods, the impact of this issue can be significantly mitigated. 64-bit systems can count time for billions of years into the future, effectively eliminating the problem. While the 2038 problem is a real concern that requires attention, it is not a harbinger of the apocalypse. With proper planning and proactive measures, the potential disruptions can be minimized or even completely avoided. The global technological community is actively working to ensure a smooth transition and prevent any major disruptions. Through collaboration and innovation, we can overcome the 2038 problem and continue to advance our technological capabilities without fear of a digital doomsday. Looking beyond our planet, some theories point to catastrophic cosmic events as the potential cause of Earth's demise in 2038. These theories often capture the imagination, painting vivid pictures of celestial bodies hurtling towards our world, bringing with them the potential for unparalleled destruction. Giant asteroids colliding with our planet, unleashing unimaginable destruction, have been a staple of both scientific speculation and popular culture. The sheer force of such an impact could cause massive tsunamis, wildfires, and a nuclear winter effect, blocking sunlight and drastically altering our climate. Similarly, rogue comets setting our skies ablaze are common themes in science fiction and doomsday prophecies. These icy wanderers from the outer reaches of the solar system can be equally devastating, with their high speeds and volatile compositions. While it's true that Earth has experienced such impacts in its long history, the probability of a catastrophic cosmic event occurring in the next few decades is extremely low. The most famous of these events, the asteroid impact that led to the extinction of the dinosaurs, happened over 65 million years ago. Organizations like NASA dedicate significant resources to monitoring near-Earth objects, NEOs, asteroids and comets whose orbits bring them close to our planet. These efforts are part of a global initiative to track and catalogue these celestial bodies, ensuring that we have ample warning of any potential threats. Sophisticated telescopes and tracking systems constantly scan the cosmos, identifying and assessing potential threats. These instruments are capable of detecting objects as small as a few meters in diameter, providing a comprehensive view of the space around us. To date, no known asteroid or comet poses a significant threat of impact with Earth in 2038 or in the foreseeable future. The data collected by these monitoring systems is continually analyzed, and any potential risks are communicated to the public and relevant authorities. Moreover, scientific advancements in asteroid deflection technologies provide us with tools and strategies to mitigate potential risks should they arise. These technologies include methods such as kinetic impactors, which involve sending a spacecraft to collide with an asteroid, altering its trajectory. The vastness of space, while a source of wonder and fascination, also offers a degree of cosmic protection. The immense distances between objects in space mean that collisions are relatively rare events. The Earth is a relatively small target in the grand scheme of the cosmos, and the odds of a catastrophic impact within our lifetime are statistically insignificant. This perspective reminds us of our place in the universe and the delicate balance that allows life to thrive on our planet. Climate change is arguably the most pressing global challenge of our time. It is a multifaceted issue that affects every corner of the globe, impacting ecosystems, economies, and communities in profound ways. The scientific consensus is clear. Human activities, primarily the burning of fossil fuels, are releasing greenhouse gases into the atmosphere, trapping heat and causing our planet to warm at an alarming rate. This warming is not just a future threat, it is happening now, altering weather patterns, melting ice caps, and shifting the balance of natural systems. While the effects of climate change are already being felt around the world, from rising sea levels and extreme weather events to disruptions in agriculture and ecosystems, it is crucial to understand that climate change is a gradual process, not a sudden apocalypse. The changes we are witnessing today are the result of decades of accumulated greenhouse gases, and their impacts will continue to unfold over the coming years and decades. While 2038 will undoubtedly witness the continued impacts of climate change, it is unlikely to be the year our planet faces an abrupt and irreversible collapse. Instead, we will see a continuation of the trends we're experiencing now, with some regions facing more severe consequences than others. The future is not set in stone, and our actions today can still make a significant difference. However, complacency is not an option. The window for meaningful action is closing, and the longer we delay, the more difficult and costly it will be to address the impacts of climate change. Every fraction of a degree of warming we can prevent will save lives, protect ecosystems, and preserve the quality of life for future generations. The choices we make today will determine the severity of climate change's impacts in the coming decades. Transitioning to clean and renewable energy sources such as solar and wind power is essential. These technologies are becoming more affordable and efficient, offering a viable path to reducing our reliance on fossil fuels. Transitioning to clean and renewable energy sources, implementing sustainable practices, and embracing technological innovations are crucial steps to mitigate climate change and ensure a habitable planet for future generations. This includes investing in energy efficiency, supporting public transportation, and promoting electric vehicles. And embracing technological innovations are crucial steps to mitigate climate change and ensure a habitable planet for future generations. Innovations in green architecture, vertical farming, and other sustainable practices can help reduce our environmental footprint and create more resilient communities. The fight against climate change requires a global effort, uniting individuals, communities, and nations in a shared commitment to protecting our planet. International cooperation is essential, as climate change knows no borders. Policies and agreements such as the Paris Agreement play a critical role in coordinating global efforts and setting ambitious targets for reducing emissions. By taking action today, we can alter the course of climate change and create a more sustainable and resilient future for all. This includes supporting reforestation efforts, protecting natural habitats, and promoting urban green spaces. The involvement of youth climate activists and community leaders is vital, as they bring energy, innovation, and a sense of urgency to the movement. Together, we can build a future where both people and the planet thrive.